And Étienne Delacroix, ladies and gentlemen, please let's welcome.
I'm only here because Armenia can break the rules. And Verhagen did a very interesting ASCII graphics rendering of the curve. That curve is a demographic curve. And is another amusing thing is that when Verhagen told me come to Armenia, it was on like mid-August, not much time. And I was working on something totally different, and I didn't have a presenter. So the presenter is working only last night, this presentation, and in some sense, and now is not the time to talk about that. I will talk about that Sunday. Sunday I can give a better talk. Now we're all tired, I am very tired, and I have to find a way to say something in little time. So, see, I have not had time to actually make this presenter work. But this presenter is fundamental. It's actually a case in jumping from top down to bottom up. As Eno said, I'm a painter, an artist, so I have absolutely no access to technology and programming circles. I do everything alone. And so, whatever tools I have used have been bottom-up tools. And bottom-up is where most people are. You here, many people here go to university, they do technology, they're in companies. This is a professional symposium. My life is at the bottom. I spend most of my time with underground people, with migrants with no papers. You have no idea. I see a world of people who have absolutely no idea of this. Except that my basic foundation was in physics. So when you do physics, especially that kind of physics I was doing, which was particle physics, you are trained to do very long-range projects. You have heard of the Higgs boson. Have anyone here heard of the Higgs boson? One person there. I don't know how you call it. Heno has. So it's very interesting. There are very few people here who know about the Higgs boson. And it was a world media event, but very quickly forgotten. But to see the Higgs boson, people had to work 40 years. And they have to build a machine during 20 years. And I just spent 15 years to build my art studio, because it was a very special art studio. So I made these general comments so that you really know from where I am speaking. And when I met Verhagen and when he asked me to talk about the work I'd been doing, and I have to find where is that work. The work I've been doing is here. It was there. I was working with those people many years. And that's 20, 25 years ago. And during that work, I had to build labs and learning places with absolutely no money. And so that's when I started looking at what I call It was computer trash. Electro-digital matter. Try to imagine what is behind that expression, electro-digital matter. Old computer, old TVs, old everything. And that's the picture of it. And most people would look at that and they say, well, we can destroy it and we recover gold or we recycle. But I saw it as frozen knowledge. Actually, in that matter, there was an incredible amount of knowledge that was not being shared. And so we started disordering these things. I would get trucks of old computers. And that's, since my presenter works only since last night, I don't have the presentation I need, but I am trying to show you, and it's almost impossible to do, but I will do it. What you see here is, on the right side, you see how we could approach this matter, look at it, and what we did with it. We started building functional elements that we could combine, and in a few years we could make small computers. They were not very powerful, but they had all the culture of design. And I call that a phenomenological approach, to use a philosophical term. I hear many people giving talks and they use philosophical concepts, but we use them with our hands. We made a phenomenology of that matter. We looked at it, we touched it, we learned how to know it. And that's, I could talk about that for a while, but I just wanted to show you one example of phenomenology. Now, we can jump 20 years until now, post-ChatGPT. That's the question. That's the question of today. And I showed you this very approximative presentation of what is the background I have to think about today. So today, this is no longer accessible. The electro-digital matter today is a nanoscale. You can't manipulate it, you can't touch it. So that the window of opportunity to do that is gone. We can still do it, but it will be only for specific case, it will have an artistic value, but fundamentally, that window of opportunity is over. And so, since I stopped doing that, I went back to pure art, and I started to write code to paint. And I don't know if you can see. Yeah, you can see. This was what I was doing before I started to teach in Latin America and do the computer trash problem, which I did only because I worked in a country that was bankrupt, there was no money, and the electrical engineering department liked my approach to thinking education, and they asked me to do a course, and that led to the phenomenology of electro-digital matter. And so now that's finished. And I went back to painting, and I've been rewriting software, a lot of software. And this is leading me to the transition to the next window of opportunity. Today we are living on top of trillions of lines of code, a lot of code that's there. No one really mastered that code anymore. It's all mangled. And it still works. It's difficult to find people to maintain it, and we keep adding new layers, and finally only people who have a lot of money can create top-down global systems that take care of everything. They think it takes care of everything, because actually it doesn't. That system, obviously, as people have tried to mention, is not perfect. It leaves many people outside. So, since the phenomenology of electro-digital matter is not possible, now is the time to do a phenomenology of code. And that's a moment that will be very necessary to prepare people to better belong to a world with ChatGPT. Post-ChatGPT is when, as some people already said, when ChatGPT will be banal, will be everywhere. There will be lots of ChatGPTs, and as I heard, the problem will be who can use that. To really use that now, you have to have a lot of expertise. And that's something, that's a big problem. I don't have time to talk about it now. Yeah. But, so this presenter here is a book. It's actually the tool I will use to write finally a book about all this work. And I'm now beginning to have it, and soon it will start to make very good presentations. That's only the embryo of it. It's a book that accesses many books. But today, I don't access anything. What I showed you in the beginning was just one moment of my story, which was this moment. And what I just showed you after about art is a previous moment. And then there is now. Now I finally have a set of software, a code base, to do the phenomenology of code with young programmers, with teens, even with children. I will not talk about that now, but I can ask one question. How would be a phenomenology of code? It would mean you look at code as a landscape. If you look at mountain, you see churches, trees, maybe river. You can identify things. But if you look at code, if you look at millions of lines of code, what do you see? What do you see? You only see words. And you also see signs, plus, minus, parentheses, all kinds of signs, operators, and that's it. That's it. Words and signs are the atoms of code. Just like, let's see, in electro-digital matter, let's see if it's, no, it's not here. The atoms are the transistors. This is really what the grain in electro-digital matter is the transistors, and maybe a lot of small things. So you have electro-digital matter that you touch. devices, and there you more or less identify some elements and you build with that. That's one way. But how will you do that with code? Then you will have to ask the first questions about words. Words in code, what can you say about it? There's two sorts of words. You have what is called a reserved word. Every language has a small set of words. In C, 32, in Java, maybe 40, or, it's just a small amount of words. So when you work with young children, 14-year-old kids, you can show them that they can enter a language by playing with a few words, like if you are juggling with a few balls. So it's when you bring them that understanding that they are playing with words, they can concentrate on a few words. But what do you do with those words? With those words, you construct like sculptures with signs. You will combine signs and words, and that will suddenly become code structures. So that the second step of phenomenology is to look at code and you say, okay, there are words, there are signs. What kind of groups of signs and words can I identify? I would be, who in that audience is a programmer? That is it. Who can program? 1, 2, 3, 4, 5, 6. Maybe half of it. Half of you is a programmer. So this game of putting together signs and words and seeing structures that you understand, only the programmers know about. This should be done in schools when they are 12, 14. And instead, top-down education has chosen another path. They use Scratch. They use Python. They use examples of tools to program where that access to visual programming is limited or distorted. Syntax is gone, and in Python you have what is called indentation, and so you suddenly lose completely the freedom of building visual structures of code as you want. But I don't want to enter into the details of this. I'm only hoping that you perceive the parallel between hardware, electrodigital matter, year 2000, and I think that's what Verhagen saw. And now, when the problem is code, not only the problem is code, but now hardware is software. We practically don't make hardware if we haven't completely modeled it with software. So the question of code is at the center. The next window of opportunity, and it's a difficult moment for me because I don't have a good talk, I don't have time, you are tired, me too. But there is one perspective ahead of me, and of certainly the young people, is when you start getting out of silicium. Right now, everything is done top-down in huge factories that are in Taiwan. There are some in America and some places in Europe, but it's mostly enormous resources to build chips. It turns out that in the beginning of the 21st century now, people discovered that carbon existed also not only as diamond or as graphite, but it existed also or as organic matter. Organic matter has carbon. But pure carbon you only have in very few types of components. But there is now awareness that we can have monoatomic layers of carbon. And that has extraordinary properties. The root of that comes from the 60s when some people started to bombard carbon with old tools that were obsolete. Tools to make chips they used to bombard carbon, and that created dust. And they analyzed that dust with a mass spectrograph, and they saw a peak at 60 carbon atoms. That was an extraordinary discovery. And then they saw that same type of signal in intergalactic space. And suddenly people started to talk about buckyballs. Maybe some of you know about Buckminster Fuller. Who knows about Buckminster Fuller? Ah, there is one person. It's remarkable. And Buckminster Fuller is an architect who had designed structures that are like football balls, and they're made of pentagons. And there is a structure of carbon made of 60 carbon atoms, and it's stable, and you can make it, and we never knew about it for 1 million years. And then they started elongating this carbon, and they suddenly finally arrived at so-called nanotubes. And then they discovered graphene by accident. Graphene is when you have a flat monoatomic layer of carbon. It turns out that electrons in that type of matter have exceptional properties, and it is my hope that at some point in small countries, in places where maybe there isn't that obsession to be a top-down master of global products, but rather someone who breaks the rules, that they will start putting some efforts in using carbon FETs, carbon transistors. These transistors, you have to understand that, this is hard for me. Oh, no, I don't have, no, I see. There it is, these things that, who is familiar with these objects? Some. I call these, to use a child psychology term, it's a transactional object of the 20th century. That. Because without that you have no TV, no phones, no nothing. And all our phones are made now with maybe 1 billion of these. The latest chips have 1 billion of these on 3 millimeters square. And it's, you know, that's phenomenology. And someone like me who is a painter trained in a physics department has the privilege but also the responsibility to try to turn that into some form of social action. That's what Verhagen captured. Only Verhagen, because they are almost nowhere. Only in Uruguay, in Latin America, there is another group like Verhagen who has worked with me and understand the potential. But that's, you know, you spend very easily to spend 15 years in pure total isolation. You don't work with anyone. But since I can paint, I can use painting to give me energy, and that's it. So I hope you just gained from this talk a sense of what could be a phenomenological approach to learning. I don't know if I managed to pass that, because it's time to go. And
you definitely did, and opening up a phenomenology of words as a concept as such also brings us back to the main, probably, let's say, thought, which was, I don't know, which it could be a thought, no, not a thought, but a concept that in the beginning there was the word. So
That's
we're getting
dangerous.
back to that, but anyways, I mean,
That's dangerous for me.
that's a dangerous topic.
Because I am an artist, alone. I don't have anymore any inscription into a collective belief.
If you could
I am
close it.
alone in front of unknown. I am constantly, every day, living that tension.
Thank you very much, Mr. Delacroix.